Hello, in this video we'll be taking a look at ScrapFly's Python SDK and how to use it for web scraping. We'll cover installation, basic use, popular features, and wrap up with an example project. To start, ScrapFly Python SDK can be found on PyPy and GitHub, so it can be installed via the usual commands like pip install or poetry. So let's take a look how to use it. To start, we need to import two objects from the ScrapFly package. ScrapFly client, which is the client object that communicates with ScrapFly API, and ScrapFly config, which is how we tell ScrapFly what we want to scrape. First, we create our client object, and for that, we need an API key which can be found on our developer dashboard. Once we have our client, we can start scraping. To scrape, we use .scrape method, which takes in a script config telling the API what to scrape. As you can see, there are many configuration options, but for the most basic requests, we can just add an URL. In this example, we're using http://bin.org HTML test page. If we run our code, we can see a result object is being returned, which contains all scraping results like HTML content, response headers, and all the meta information. We can also see a direct link to dashboard log URL, where we can see all of these details in a nice UI. The result object also contains some convenient features like built-in HTML parser. For example, we can use CSS selectors or XPath to parse HTML results. For other Python developers familiar with Python request module, the results can also be cast to a request response object, which makes it easy to integrate ScrapFly SDK with existing scraper code. Alright, let's slow down a bit and take a look at some popular ScrapFly features. To start, when developing with ScrapFly SDK, we should use cache and debug features. The cache feature will greatly speed up repeating the same requests, as the results will be taken from ScrapFly database rather than the target website. And the debug feature will store the scrape result in the ScrapFly dashboard, so we can come back to it at any time and reanalyze the scrape process in case something goes wrong. You can see the details about these features in the ScrapFly dashboard. Next, let's take a look how to make different types of requests using ScrapFly SDK. Just like with any other HTTP client, we can send any type of HTTP requests. We can change the request method from default GET to POST. We can also add request body, headers, and cookies. In this example, we're making a form POST request with some custom headers and cookies to the HTTP bin test site. The response shows us what details we sent. The request body, headers, and cookies we set in our config. Next one is the most popular feature of ScrapFly, and that is anti-scraping protection bypass. This feature allows scraping of pages that block web scrapers using anti-scraping technologies like Cloudflare or Perimeter X and others. Here, by enabling ASP, we can easily scrape Crunchbase.com, which uses multiple anti-scraping technologies to block web scrapers. For more on blocking, ScrapFly also offers a variety of proxies by type and origin country. For example, to access geographically locked pages, we can specify the country parameter. Here, in this example, Yelp.com is only available in the US, so we're using US residential type proxy to scrape it. For all available proxy details, you can check the proxy section of the ScrapFly dashboard. With all that, the biggest feature of ScrapFly is its headless browsers. ScrapFly can use real web browsers for web scraping. This is particularly useful when scraping web applications that require JavaScript to function, for example, Twitter. By enabling the render.js option, we can tell ScrapFly to use a browser for this request and return the fully rendered page contents. Note that for websites that take a while to load, we can use wait for selector option and tell ScrapFly browser to wait for some specific element to load explicitly. Render.js feature also enables access to other features like screenshot capture, so we can see exactly what ScrapFly browser sees. Other more advanced features like JavaScript evaluation and JavaScript scenarios give us full control of the cloud browser. You can input text, click buttons like you would with a real web browser. These are just some of the most popular features supported by ScrapFly SDK. For more, see our full documentation. ScrapFly also includes several options for parsing data using AI models or direct parsing instructions through ScrapFly Extraction API. This API can be directly accessed through ScrapFly Python SDK. So let's take a quick look. To access the extraction API, the same ScrapFly client object is used, using the extract method. And the extract config object is used to specify extraction configuration. Let's take a look at some examples. To start, large language models can be used to prompt text content. This can be used to extract data or ask any free-form questions. For example, let's ask the LLM a basic question like, what is the price of a product on this webscraping.dev page? For this, we must first retrieve the HTML either from our own storage or scrape it using the WebScrape API. Then, we're using the extraction prompt parameter to supply our prompt, which in this case simply is extract product price. We can find the result under extraction result key, and the dataset contains two fields, the extraction result type and the result itself. Here, we can see that it correctly identified product price as $9.99. We can also prompt for specific result formats, like JSON or CSV. In this example, we're using prompt extract product price and currency as JSON, which returns data in JSON format. For more on LLM-based prompting, see our full documentation. Next, let's take a look at AI auto-extraction. AI auto-extraction is ideal for extracting popular data objects like products, reviews, property listings, and similar. In this mode, a predefined AI model is used to find all relevant data of a defined object. For example, let's use our webscraping.dev product page again. Here, we're setting extraction model parameter to product, and the AI model will try to find all relevant product information on the page. Here we can see the API has returned us a JSON object of all product details it could find, like price, description, and images. It also returns a data quality meta field that indicates how many fields were found. For available object types and their fields, see the full documentation. Finally, let's take a look at the last extraction method that allows us to create extraction rules explicitly. Extraction templates can be used to define exact data parsing rules, using more traditional parsing techniques like XPath or CSS selectors. The extracted data can also be cleaned up using extractors and formatters. Let's see an example. For this, we'll be using reviews listing page on webscraping.dev and extract all review dates in custom format. Here, we provide our extraction rules using the ephemeral template parameter. For our extraction, we're using CSS selectors to select the date text and apply a datetime formatter to change the date format. This is just the tip of the iceberg when it comes to extraction rules feature. And for more in-depth examples and all available extractors, formatters, see the full documentation page. Next, let's take a look at how to access another ScrapFly API, the Screenshot API, using the Python SDK. While it's possible to capture screenshots using ScrapFly WebScrape API, there's also a dedicated Screenshot API, which is also accessible through the Python SDK. Using the ScrapFly client screenshot method, we can request screenshot capture of any page or even part of the page. Let's take a look at some examples. To start, Screenshot API can be accessed using the same ScrapFly client. Then, the screenshot config object is used to define screen capture instructions. In this basic example, we just provide a page URL to capture. This captures the default 1920 by 1080 resolution, but we can change that using the resolution parameter to emulate viewports of different devices like smartphones or tablets. In this example, we use 540 x 1200 resolution to capture a mobile viewport of the website. We can further extend the capture beyond browser viewport using the capture parameter. Here, we set capture to full page value to capture the entire page. The capture parameter can also be used to capture specific elements using XPath or CSS selectors. In this example, we set the capture parameter to CSS selector for capturing only the review section of the product page. Another useful option is the auto-scroll parameter, which when enabled will scroll the browser to the bottom of the page, allowing to capture pages like this endless paging example. Here, the auto-scroll scrolls the testimonials page to the very bottom, loading all the items before capturing the screenshot. More capture configurations can be done through options parameter, which can apply common page modification scenarios, like closing cookie banners or applying dark theme styling. In this example, we use the block banners option and dark mode option to disable cookie banners and apply dark theme. For more available options and other screenshot parameters, see the full screenshot API specification. Next, let's solidify some of this knowledge by taking a look at a quick example project. In this example project, we'll be scraping business pages from Yelp.com using ScrapFly SDK. We'll keep it brief and scrape essential business details like the name, website, phone number, and the address. We'll also take a look at scraping Yelp.com's search to discover these business pages. Alright, let's start by setting up our scraper using Poetry. For that, all we have to do is initiate a new project with ScrapFly SDK as a dependency. We're using the All option to install SDK with all of its features for this example. This command should generate our project file and a new virtual environment. To enable this virtual environment, we can click here at the bottom and select it. Alright, now we can start scraping. For this project, we'll be using CSV module to output our data to CSV file. We'll also be using Asyncio for fast asynchronous scraping, and we'll also be defining some basic types to help us along. And of course, we'll be using ScrapFly SDK. To start, let's create a ScrapFly client with our API key, which can be found on your ScrapFly dashboard. Okay, so the first step of our scraper is to collect the HTML pages. And for that, we'll be using scrape businesses function. This function takes in a bunch of URLs in the form of a list and generates the results. So the first thing it does, it converts the URLs to scrape configurations. In this example, we're using country setting for proxies to US. We're also enabling anti-scraping protection bypass in case Yelp wants to block us. And finally, we're using cache to speed up our scraping in case we need to repeat our requests while developing the scraper. Once we have our scrape configurations, we want to scrape them concurrently using the concurrent scrape method. We also want to parse every HTML result. For that, let's take a look at parse business function next. In this function, we'll be using CSS and XPath selectors to find the data in the HTML page. To create these selectors, let's take a look at the business page itself. Alright, for this we'll be using Chrome Developer Tools. You can access these tools using F12 button or by right-clicking anywhere on the page. For example, if we right-click on the name and click Inspect, we can see exactly where in the HTML this element is located. You can see the name is under H1 element. So to extract the name, we would be using CSS selector H1 text. The other fields are a bit more complicated. Let's take a look. If we take a look at the phone number, we can see that it's located next to a sibling element with text phone number. So to extract it, we can simply find this text and then select the first sibling, which is the value. So using XPath, we can select the paragraph node that contains text phone number. Then we simply select its first sibling and select its text. So let's put this to a quick test. In this example run function, we have 3 URLs of 3 Yelp.com businesses. Then we feed those URLs into our scrape businesses function. And for each result, we'll open businesses CSV file in append mode and write the result. End up looking something like this. Let's run it. You can see new businesses keep appearing as our scraper is going. Get the URL, the business name, phone number, website, and the address. Next up, let's take a look how to scrape the search pages. The first thing we notice that there are 10 or so results per page, and there are multiple pages of results. We also have the total number of pages. To scrape this quickly, we'll be using a common pagination web scraping technique. Let's take a look at it. First, we'll scrape the first page and find the total amount of pages. Then we can scrape the remaining pages concurrently, which is faster than scraping them one by one. Here we are scraping the first page, and then we use CSS selector and a bit of regular expressions to find the total amount of pages. Then we create a scrape config for every page and schedule to scrape them concurrently. As for parsing the search for business data, we're using CSS selectors again. So if we take a look at the search page using DevTools again, we can see that every result is contained within its own element box. So what we can do to select these elements is use the data test ID attribute. So that's what we do in our scraper here. First, we iterate through each of these boxes and then parse the results, like URL, name, and rating. Let's try out our search scraper by scraping for tacos in Toronto. Just like with businesses, we're feeding our search URLs into our scrape function. And then for each result, we're opening up CSV file in append mode and writing the results. So if we try this out, we can see search file is being created and the results are streaming as the scraper is scraping new data. This wraps up our quick introduction to ScrapFly. To summarize, first, we create a ScrapFly client with our API key that we can find on our dashboard. Then we create our scrape config objects, which define what to scrape. And to schedule the config, we can use one of 3 available scraping methods. The scrape method is the most simple one, and it's synchronous and can be called from any script, while async scrape and concurrent scrape require asynchronous frameworks like Asyncio. So finally, all of the code used in this video can be found on GitHub. And for more on ScrapFly, check out our documentation pages and our blog. And thanks for watching.